Hello friends, today's question. A homogeneous solid cylindrical roller of radius r and mass m is pulled on a cricket pitch by a horizontal force at center. Assuming rolling without slipping, angular acceleration of the cylinder will be. So we have a cylinder which is being pulled by a force, horizontal force applied at the center. So let us F is the applied force at the center, and this is the pitch, and we have a angular acceleration of alpha. So we are supposed to find out what will be this value of angular acceleration. Okay. Let us suppose P is the point of contact, and at this P point of contact there will be a frictional force acting on between the cylinder and the pitch, and let us suppose that is given as F of R. Therefore we can say there are two forces acting on the cylinder. Okay. Two forces acting on the cylinder. First one will be the applied force. Applied force F, and second one is the frictional force at the point of contact. Frictional force Fr at the point of contact, that is P. And we can also write the motion for the translational motion as well as for the rotational motion. You can say for translatory motion, and if A is the linear acceleration, then we can say F minus Fr is equal to mass into acceleration, where this, let us call this equation 1, and A is linear acceleration. And for rotational motion, the rotational motion will be produced because of the torque that is acting on the cylinder. So we can say the net torque acting about center of mass. So we can write tau is equal to moment of inertia multiplied by alpha, that is angular acceleration. And we can also see that this friction will be generating the torque for the angular acceleration of alpha. You can say the torque is due to frictional force Fr. Therefore we can write that our tau is equal to Fr multiplied by the perpendicular distance, which is nothing but a radius, that is R. So let us call this as equation number 2 and this as equation number 3. So from 2 and 3, from equation 2 and 3, we get I alpha is equal to Fr multiplied by radius, and the moment of inertia for a solid cylinder, moment of inertia for a solid cylinder is equal to half mr square. So substituting this value, we get that Fr is equal to half, and this is multiply product of radius, also this is half m r square multiplied by angular acceleration of alpha. Square goes away, so from here we get frictional force is equal to half m r alpha. Let us call the equation number 4. Now for the condition of rolling without slipping, condition of rolling without slipping, A will be equal to alpha multiplied by R. So from equation 1, we get F minus Fr is equal to m multiplied by alpha multiplied by R, and Fr we just calculated, so we can say using equation 4, we get F minus 1 by 2 m r alpha is equal to m r alpha, or we can say that F is equal to m r alpha plus 1 by 2 m r alpha. So we get this as F is equal to 3 by 2 m r alpha, and we are supposed to find out the angular acceleration. So we can say alpha is equal to 2 times force divided by 3 mr. So this is the value of angular acceleration. This is the angular acceleration. So if the option available to us, you can see it is 3F. C option is available to us. Sorry, not C, it is 2F. My mistake. 2F. Option B is correct. So we can say option B is the correct. Is correct. This completes the question. Thank you.